Okay, in this question, they've given us a neutralization reaction between hydrochloric acid and sodium hydroxide. This is an exothermic reaction that produces 57 kilojoules for every mole of reaction as written. They would like us to determine three things in this question. Part A, what would the heat release be if we mixed 50 mils of 1 molar hydrochloric acid with 80 mils of 2 molar sodium hydroxide? Then in part B, they'd like us to determine what would happen if we doubled the amount of sodium hydroxide, and in part C, what would happen if we doubled the amount of hydrochloric acid. Let's go ahead and start by writing down our data. They've given us some information about hydrochloric acid. What they told me about hydrochloric acid is we have a molarity of big capital M, 1 molar, and we have a volume of 50.0 milliliters. They also gave me information about my sodium hydroxide. They told me for my sodium hydroxide, the molarity is twice as strong, 2.0 molar, and the volume is more than we have of the volume of hydrochloric acid. It is 80.0 milliliters. Okay, again, one of these is going to be a limiting reactant. One of these we're going to run out of first. They gave me information about both. Now, you can probably guess which one it is right off the bat. Looking at hydrochloric acid and sodium hydroxide, we need a 1-to-1 ratio. However, our sodium hydroxide is twice the concentration, 1 molar versus 2 molar, and they've gone more than 50 mils. So we've added more sodium hydroxide and it's more concentrated. The sodium hydroxide is going to be in excess. But let's go ahead and prove that. Let's go ahead and solve for the moles of each of these and then see which one of those is going to give us the least product. Which product? I don't know. Let's just do water. Let's go ahead and begin with the hydrochloric acid. If we want to go ahead and find moles of hydrochloric acid, your moles is equal to N, molarity times volume in liters. The moles of hydrochloric acid that we're going to have is our 1 molar concentration times the volume in liters. Let's go ahead and take that 50 mils, divide it by 1,000 to get our liters. That's 0.0500 liters. That tells me for hydrochloric acid, we have 0.0500 moles. Okay, 0.0500 moles. Now let's go ahead and do the same thing with our sodium hydroxide, our NaOH. Moles is molarity times volume. Our moles is going to be a molarity 2.0 molar times a volume in liters. Again, let's change those 80 milliliters into liters by dividing by 1,000. That's 0.0800 liters. If we double 0.08, what we get for our moles in this case is 0.16 moles. 0.16 moles. Okay, we can clearly see which one of these is going to be our limiting reactant. It's supposed to be a 1-to-1 ratio. We should have the same amount, but we have well over double the amount of sodium hydroxide here. We knew that. It was twice as concentrated and they added extra. So the sodium hydroxide is your excess reactant and the hydrochloric acid is your limiting reactant. Remember, the heat produced always goes off of the limiting because once it runs out, we're not going to produce any more heat. So let's go ahead and use some dimensional analysis to figure out how much heat is produced from our limiting reactant. We're going to start off with our moles of limiting reactant here. We've got 0.0500 moles of our HCl. We're going to change that into kilojoules. I'm going to go ahead and get rid of moles of HCl. And I'm going to go to kilojoules. And what I know is for every 1 mole of HCl, I produce 57 kilojoules of energy. 1 mole, negative 57 kilojoules. Now, your moles cancel out, cancel, cancel. And if you take 0.05 times 57, you get negative 2.9 kilojoules. That's how much energy will be released. All right, let's go for parts B and C of this question. Part B says, what's going to happen to the heat that's released if we double the amount of sodium hydroxide? Well, notice, sodium hydroxide was your excess. We already had too much. If we go ahead and add extra sodium hydroxide, nothing's going to happen. No extra heat will be released from this reaction. What if we release, or what if we double the amount of hydrochloric acid on the other hand? Hydrochloric acid was our limiting reactant. If we add more, well, more will get used up and we should release more heat. In fact, if we double the amount of hydrochloric acid, it will still be the limiting reactant. This will go from 0.05 to 0.1. We still have less of it. So we're going to use up all of the extra amount. We would use up 0.1 moles of HCl, and that would double the heat released from this overall reaction. I hope that helps. Take care.